That's not right.
Yeah,
It's the 4 plus 12 minus
it was
4.
the best way.
Yeah. Yeah.
With,
Oh, that was the 4 was 52. Yeah. Yeah. And the fifth one's competition.
you know, the goal is to keep
Yeah.
denominator.
Yeah.
Like the BMW.
Yes, it's like a possibility to be
Is the second one also independent?
Yep.
Okay.
Yep. Here, just so you see the connection.
Uh-huh.
See how both of these say if A and B are independent ends?
Well, on the second one
All
after.
I did was take that math formula and substituted that there,
Okay,
and the PB's cancel.
got
So it's only true if this is going up.
got it.
So that's what I'm doing. This is true for all cases.
Okay.
I'll emphasize that.
Now this event has to be consecutive, not simultaneous events, right?
Right.
Okay.
Good. Is it spring break?
Early spring break.
Hey, our next test isn't until Thursday of next week.
Say no more.
Cool. You'll be here, right?
Of course.
Okay. Because we lost 2 days. We're 2 days. You can just, every time you see it, all right, it's 2 days out. Yeah,
So is that's the day before spring break starts, right?
that's right.
Okay. So not, okay, next Thursday, got it.
Yep. The day before the last day for spring break, that Friday. That worked perfect. I wouldn't want it to linger over spring break anyway.
Well, so my admin teacher.
I know we think logically you think we get more time to study.
I don't know
Never
how
works.
she's on purpose, but
That's how my dad like it. Instructors
it's like,
you know, you're
Never.
study with a late
It doesn't.
Oh, is it Friday?
It's like a late one.
Finals is a whole different story. You'll get ready for finals. Just
Oh, really? What, Tampa?
Yeah.
hey, good afternoon, everyone. We're gonna do 5-3 and 5-4 today. 5-3 is we actually got into 5-3 a little bit in the last lesson, but we'll start right where we left off. They call this the multiplication rule for probability because yeah, it's probably A and B occurring. We just multiply the two events, but you can only do this if the events are independent. Don't let that phrase independent events, intimidate you when you see that. But, in any scenario, we can always think about it and go, are these events truly independent? If you don't think they are, please feel free to, raise your point if you're reading a problem out of the textbook. But last thing I was doing was the roulette wheel. And so I thought I'd do another one. And the roulette wheel, you don't have to memorize this roulette wheel, but there's a total of 38 slots, and 18 are black, 18 are red, 2 are green. And we did this idea of, playing the game a few times. Well, I think we did 6 times last time, right?
Mm-hmm.
All right. Let's do 8. And this sounds crazy. I want to say, what's the probability? This is a little metal ball. The metal ball falls in a red slot 8 times in a row. All right. The probability that the little metal ball falls in a red slot 8 times in a row. That means 8 times consecutively. All right. In a row. Question mark. That means consecutively. Eight times in a row, 8 times consecutively. Play the game 8 times. Red, 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 red. So as you're copying this, is this or is this and?
And
You know, you read this problem, and sometimes you have to put it in your own words. Because we're thinking, basically with the probability, basically, we know we have these rules. But or, when we hear or, we think add probabilities. This idea of and probability, we think we have to multiply probabilities. Well, I don't see anything about an or and an in here, but if we put it in our own words, 8 times, we're like, I'm gonna play this game 8 times. It's gotta land on red, and then again it's gotta land on red. And it's gotta land on red, and then it's gotta land on red, and it's gotta land on red, and it's gotta land on red. So this is an and. And this is that multiplication rule. And they're definitely independent events, everyone. The idea of independent events, if you need a refresher on that, it's the occurrence of event A does not alter the probability, you know, of B occurrence. So just playing the games over and over I won't get better at the game, right? It's just like over and over and over again the same probability of getting it in a red slot. So what's the long way to do this problem? Well, for that first attempt, 18 reds out of how many slots?
38.
Something for the first event. But since I got to multiply them, and I actually like to write all this out, because who knows, a student may like to write it this way, type it this way. Also, when you see it presented this way, it helps you remember it. It really does. All these got to multiply. That's first, second, third, fourth, fifth attempt. Here's the 6th attempt. I've got another 18 and 38 chance. 7th attempt, and then my 8th attempt. And they're all ands, so we're saying we're multiplying all this. Independent of that. 1, 2, 3, 4, 5, 6, 7. And what's a quick way to type this on a calculator?
2 to the power 8.
18, divide 38, close your parentheses, and raise it to the
8 power.
8th power. Who's got the cool new calculators? You got one, right, Hal? You got math print mode?
Yeah.
So math print mode, everyone, she has it like this. She hits this caret button on her calculator. It automatically puts a spot right here for her to put the number. And she'll just go like that. That means 18 over 38 to the 8th power. But who's got the old TI-83s? Mine's like a TI-83. What we have to type is 18 over 38. Actually, it looks like this on the screen. 18, we hit the division button, we hit 38, we close it, we hit the caret, and then we raise it to the 8th power. That means raise to the 8th power. So that's a fast way to do it. And yeah, you're encouraged to do it that way because I might mess that up. Now, do you get something silly?
Yeah.
It might be in scientific notation. Remember? Start looking for that. Very, very small probabilities are written in scientific notation. What's your screen say? I'd love to see yours.
Mine is different.
Yours is different, but I see a -3. 0.0025. All right. It wasn't in scientific notation. I do want to point out, everyone, if you start seeing numbers like this, I don't even want to round this to 1% because it's a lot smaller, isn't it?
Mm-hmm.
And what that means right there, if I just said that, that's 2 out of 1,000. Try it 1,000 times, do this. You might do it twice, right? Maybe. That's 25 out of 10,000 times. But you might start seeing numbers like this in this course. I like to write this number. 3.2, a bunch of values, and then E -5. Remember, that's a very, very small probability. It's in scientific notation. It means 3.2 times 10 to the -5. If you like to write that as a decimal, boom. How many zeros after that decimal point?
4.
4. Okay. 0, 0, 0, 0. Then I'll write the 3 and
2.
2. So you can see how small that is. So start on all these problems. Yeah, purple vision. The whole screen. All right. Check it out.
Can you write like 3.2 times 10 to the power -5?
I love that. So feel free to write this probability like this. You write it like this, You could write it like this. I mean, that's a probability. In terms of probability, we'll never go over 1.0, right? Just don't write this, right? That means 320%. We're like, no, right? Not in probability. So be careful. If you got answers like that, we made that up. Pretty good deal. Like, I'm curious, when I'm gonna erase, can I erase all that? All right, I'm gonna erase this, I'm gonna leave this. And what we're saying is 20 times in a row.
Oh my God.
So that would be a what here?
20.
Maybe that'll do it. That'd be so small, the chances of doing that. Don't you agree? It's like, that wouldn't happen. I'm like, well, it could. It could. Yeah, watch out. Look at the chances of doing something like that. We're talking about a fair game, right? This game isn't rigged. For it to do red, and keep doing that. Crazy. So, I'm gonna check out someone's calculator. Cool, thanks, Holland. 3.23, a bunch of numbers. 3.23, bunch of numbers after that, and that says E negative 7. Now, Michael, you can just leave the answer like that. I mean, that's a probability. But if you want to raise a decimal point, how many zeros?
6.
6. Good. I'll go 1, 2, 3, 4, 5, 6, and then a 3. And we're basically saying close to 0 chance, right? Close to no chance. That's what we're saying. Chances I win the lottery, right? There you go. Hey, so I'm going to start pulling some technical problems from section 5.3. I'll make sure to put the problem number on the board. This is on page 284. This stuff's fun. Probably pretty cool. On page 284, how about number 13? It's titled South Paws. South Paws, I'm a lefty. Who else was a lefty? 1, 2, 3, there's 4 of us. I can remember this. All right, we're the lefties, we're the southpaws. Well, let's see, they give the probability someone's a softball, just a random person. They said about 13% of the population is left-handed. Now, and that's true. About 13% of the population is left-handed. All right, I'll just put that on the board. And the probability you got a lefty, a randomly selected person that they're left-handed is 0.13. Or if you want to write it like this, go ahead, 13%. It's 0.1. All right. First question. I bet you crushed this. If 2 people are randomly selected, what is the probability that both are left-handed? I'll write that on the board. If 2 people are selected. Notice he said randomly. They didn't go to like a lefty club, right? Right. 2 people are randomly selected. All right. They said, what's the probability that both are left-handed? Both are left-handed. The reason I wanted to write this on the board is because the wording. We gotta figure this out. Is this or is this and?
And.
Hard, very good. I mean, I don't see it anywhere, right? I searched both. There's a keyword, both. Maybe that's the buzzword. It's like, here's the 2 people. This person's left-handed and this person's left-handed. We're looking at that probability, right? And so, all we have to do is take this and
Multiply.
that's probably the first person left-handed and the second. And can we assume they're independent events? Yeah, I see this word randomly. Randomly. So there's randomly selected people, absolutely. It's like me going right on the campus. Just randomly selecting 2 people. Well, the next 2 people walk down this hallway. It's like, hey, you lefty? The chances are small though, look at this. What's the chances of this?
0.0169.
I mean, does everyone agree this would be unusual? So for our class, we'll consider anything under 5% unusual. Sound good? Anything under 5% we'll think is unusual. Well, that's under 5%. This would be very unusual. rare for that to happen. And you're like, really? Just 2 people? I know.
Is this like
Just
the
to get
standard deviation after 2 deviation is unusual? Same logic? Okay.
That's exactly it. And then when there's another question coming up, you'll get used to it. It's gonna come out a few times today. I'll keep it this over and over again. You'll probably get tired of me doing it. The phrase "at least one." All right, so here you go. What is the probability tell you what, I'll put a yellow A right here. We still have if 2 people are randomly selected, right? Put a big box over there. All right? Right here, I'll put a little letter A. What is probably that? Letter B. So it's coming off this statement. So forget about both being lefties. Here's the question. What's the probability that at least one is right-handed?
So out of the 2?
Yep.
Also, then isn't there a complex